All right, welcome to Wednesday's math menu. Again, the first thing that we're going to start with is circling prime numbers. And at this point in time, you should have some practice with identifying what factors there are to represent each of these numbers, and then deciding whether or not it only has one in itself, or if there are multiple factors, making it a composite number. In this case, we are looking for prime numbers. So when I look at 7, I know the only way that I can get 7 when I multiply it is 1 times 7, so it is a prime number. 12, 1 times 12, 2 times 6, 3 times 4. So it has more than just 1 in itself, so it is a composite number. 15, 1 times 15, 3 times 5, composite. 19, 1 times 19, it is a prime number, so we are going to circle it. The number 25, we have 1 and 25, and then 5 times 5. It is composite. 36 has multiple factors, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, so it is a composite number. 40, I have 1 times 40, 2 times 20, 4 times 10, 5 times 8. It is a composite number. 41, I know that I can do 1 times 41, and then just like you all, I have to kind of run down my factor list, and I have to think, will 2 go into 41? Nope, nothing I can multiply there. 3, if I divide 3 into 41, not going to work. 4, 5, okay, so it is a prime number, so I'm going to circle it. 45, I have 1 times 45, 5 times 9, so it is composite. So in this case, I have 7, 19, and 41 as my prime numbers. 64 times 47, when I multiply that there, again, I can choose the traditional strategy, or I can do the box method. For the box method, to break each number down into expanded form. So I have 60 and 4, and I have 40 and 7. And I like to draw the little line so I know what needs to go in each box. So I would do 40 times 60, 4 times 40, 60 times 7, and then 7 times 4. Okay? 40 times 60, again, 40 times 60. I'm not going to find that on my multiplication chart, but I will find 4 times 6. And 4 times 6 is 24, 2 zeros, so we call that mental math. 4 times 4, 16, and 1 more 0, mental math. 6 times 7, 42, 0. 7 times 4, 28. Here comes the challenging part, making sure I line everything up. So I need to keep place value in mind. I have 2,400. So if I have 160, there's only 3 digits in 160. When I go to line up a number, I always want to start in the ones column. So I would do 160. 420, it has 3 digits, so it should line up right underneath the 160. And then finally, I have 28. And when I add those up, 8, 6, 7, 8, 9, 10. Regroup my 1 there. 4, 5, plus 4 is 9, and 10. Regroup my 1. 2 plus 1 is 3. 3,008. Okay? And then finally, on our appetizer, we have a long division problem, which again, I'm going to use the box method. 3-digit number. How many columns do I need? I need 3. So I have 5, 8, 8. I'm dividing by 5. 5 goes into 5 one time. The answers go in the attic. Remainder goes in the chimney. 5 times 1. Remember my steps. Divide, multiply, subtract, bring down, repeat. So it just divided. Now I'm going to multiply. 5 times 1. 5. When I subtract, I get 0. Bring that 0 up. Doesn't change my 8. So this time I have 5 into 8. 5 goes into 8 one time. 5 times 1. 5. I'm going to subtract because I'm on step 3. 8 minus 5 is 3. Add that to my 8. I have 5 into 38. I know that if I multiply by 7, I get 35. And when I subtract, I am left with a remainder of 3. And there is a remainder because I have nothing else to bring this 3 over to, or if I were doing the traditional method, I have nothing else to bring down. Okay? After you have checked those problems, you are going to flip over to your main course. Today's main course, let me move this up a little bit so you can see the top, is identify the lines of symmetry. How many lines of symmetry do these figures have? And hopefully we know from years past that a line of symmetry is essentially if I were to fold an image in half, both halves would match exactly. Okay? So it's kind of like a reflection of the other half. So a line of symmetry is if I were to fold the image, both halves would match exactly. Okay? I have actually cut out a couple shapes I was going to show you under the dot cam, and we were going to kind of fold them together and see what we think. Because for this main course, you're going to have to identify how many lines. So how many times could you fold the shape and it would match up exactly. Okay? This first shape I have is a triangle. So if I were to fold it, now remember it has to match exactly. I'm already seeing that I could fold it, and please don't mind my cutting job, but I could fold it at least once. So there would be one line of symmetry. Now if I fold this down, that doesn't match. So that's not going to count. Okay? If I try to fold this corner up, nope. This corner, nope. Okay, so for this shape, there is only one line of symmetry along the middle here. One line of symmetry. Okay? Now, don't be deceived, because some shapes, and you're going to find when you start drawing these out, that it's going to look like it would fold, but then if you actually were to cut out the shape and fold it, it doesn't match up. Okay? This next shape I have is kind of like it's an odd shape. All right? If we were to fold it in half this way, it doesn't match. Okay? So that is not a line of symmetry. If I were to fold it like this in half, again, not a line of symmetry because the two sides are not exact. So this shape would have 0 lines of symmetry. Okay? I have one more shape to show you, and that is kind of an arrow shape. Now if I fold in the middle, those two sides match. Okay, so I see that there's one line so far. If I were to fold it in half this direction, I'm not going to see that those match. So that is not a line of symmetry. So this shape, just like our triangle, only has one line of symmetry. Okay? I also printed out kind of a little cheat sheet to give you an idea of what it looks like when you start drawing some of these lines on your shapes. And you're probably going to see some of these shapes on your worksheet. So you might want to take some notes. Be careful that when we go corner to corner, obviously a square, all 4 sides are the same. So in this case, a square is going to have 4 lines of symmetry. A rectangle has 2 pairs of parallel sides and equivalent sides. So that means these 2 sides are equal and these 2 sides are equal. So a rectangle, unlike a square, only has 2 lines of symmetry. A rhombus, which is more of kind of a diamond shape, is going to have 2 lines of symmetry. A kite, you're going to see if I were to fold this corner up, it's not going to match, so it only has 1 line of symmetry. A trapezoid, this type of trapezoid, because our sides are not matching up, it's not a mirror image, that this is not going to have any lines of symmetry. Finally, a parallelogram, deceivingly, this one is often mistaken for having lines of symmetry, will not have any lines. If I take this corner and try to fold it to this corner, it's not going to match up. Equilateral triangle, unlike the one that I showed you, is going to have 3 lines, and the final triangle was the one that I showed you just a moment ago that I had cut out, is an isosceles triangle, and it is going to have 1 line of symmetry. Okay? So when you go to work on the main course today, you need to, I would draw it out, and in my brain, I would imagine if I were to fold it, what would it match up side to side? Okay? You need to write down here in the gray box under the shape how many lines. So how many times can you fold it and the 2 sides would match up identically. When you have finished this, you are going to move on to complete your MobyMax lessons, and there will be some games available on Math Google Classroom.